So it's an algebraic method, okay? The goal is to get one equation, y equals or x equals. That's our first step. Now, if you look, we have two equations here. I find it helps to number our equation. We'll call the first equation 1 and second equation 2.
Very creative.
Yes, very, very creative. Bob and Phil. Okay, so which equation is it going to be easier to isolate one of the variables for? It's actually the first one. For which letter? X. Whoever has a coefficient of 1, it's going to be easier to isolate. So let's step 1 in this one. So step 1, we're going to isolate X in equation 1. In Bob. Is it Bob and Phil? I forget.
Yes.
Okay, in Bob. Okay, so we're going to isolate. You can call it whatever you want. You really could call it Bob and Phil if you want.
That's actually what I wrote.
That's funny. Okay, so let's get X by itself. How do I get X by itself? Subtract 4y from both sides. That's really up to you. You can write that as negative 4y plus 6 or 6 minus 4y. It really doesn't matter. What do you want? Negative 4y plus 6. You're so used to doing that, so let's do that. Negative 4y plus 6. Okay, that was step 1 done. Check. There's going to be 4 steps. Yep, 4. So a lot of work, a lot of algebraic work here. Step 2. And this is the part that might take some time to really explain to you, okay? Step 2 is now that we have one of the variables isolated, we're going to actually sub that into the other equation. It's like inception. Because that point, the point of intersection, the x values and the y values are equivalent to each other. Okay? So what, in this case, our step 2 is to sub our x equals that we isolated for into the other equation, which in this case is Phil, into number 2. Okay? So what do I mean by that? Well, let's write down equation 2. Equation 2 is 2x minus 3y equals 1. Okay, so we're going to replace which variable? Well, which variable did we isolate? X. So we isolated x. And what did x equal? Negative 4y plus 6. So we're going to actually replace x with what it equals. It's like inception. I have an equation inside an equation. What? Okay, so x is equal, it's an actually expression. X equals, Mr. Ration. So great. Okay, negative 4y plus 6 minus 3y equals 1. Did everyone see what I just did there? Let me scroll up. Okay. So what does that do? Now we have an equation with only one variable. If we have an equation with only one variable, we can just do some simple algebra and actually solve for that variable. Cool. So let's do some algebra, distributive law, connect like terms, la-di-da, and get y by itself. Yeah. Okay. Phil and Bob met.
Bob is now inside Phil.
Haley. Haley, you're supposed to be a good girl. Okay. So 2 times negative 4y is negative 8y. Plus 2 times 6 is 12. Minus 3y equals 1. Or, collecting like terms, negative 11y plus 12 equals 1. Now what? Isolate y by minus 12. What's 1 minus 12? Negative 11. So negative 11y equals negative 11. Divided by negative 11. Y is 1.
Oh, that works. That's a lot of steps for step 2.
I know. Step 2 is the longest step.
Oh, that was all step 2?
That was all step 2. Okay, 2 more steps. But the hard part's over. Okay, now that we know y is 1, okay, step 3 is quite simple. Step 3 is sub our solution, in this case, sub y equals 1 into either equation. Which equation would you like to do? Probably the easiest is 1. I forget who's here.
Bob is 1. Bill is 2.
Okay, so now here's the cool thing, guys. We have 2 equation 1s. We have the equation 1, the original equation 1, but we also rearranged equation 1 over here. Those are both equation 1. Would you agree with that? Same thing, just written a different way. So it's really up to us which equation 1 we use. Which one's easier? The second one, it's x equals. It's just going to be a straight like plug in and play. So x equals negative 4 times what's y? 1 plus 6. X is what? Negative 4 plus 6? 2. So we got x equals 2, y equals 1. So our last step is algebraically we need to do a check. We did all this algebraic work. And so it's easy to make simple algebraic mistakes. How do we do a check?
Plug it in.
Just plug it in. Okay, so use our original equation. Whoa! Oh.
Oh.
No, I'm so not okay. Okay. I know, my husband fell off a roof yesterday, so. Yeah. Okay, so check. When you're checking, no, it's working. 2x minus 3y should equal 1. We sub it into the original equations. So 2 times, what was x?
It's checking stuff.
It's part of your marks.
No, but is that step 4?
Yeah, oh yeah, sorry, this is step 4. Yeah, here's your check. 2 times 2 minus 3 times 1 has to equal 1. Is that 1? 4 minus 3? That's 1. Good? And the other original, we always use the originals, just in case we made a mistake rearranging our equation. X plus 4y equals 6. So, x was 2 times 4, or plus 4 times 1. 6 equals 6. Lots of writing, hey? I gave you a full page, didn't I?
No. Like half a page.
Oh, yeah, because it got formatted bad. Okay, let's try another one. Turn the page.
That was a really bad page.
I'm so upset.
Blame the students. Blame Bob.
No. No, it's lying. So remind me never to trust you, Victoria. No, it's okay. I will deal with it. Okay, equation 1 and 2. What should we rearrange? Step 1. Who are we rearranging? 1 or 2? Isolate who? Who's the easiest one? Come on. Bob. Okay, isolate 1 for what letter? So y in 1. Okay, whoever has a coefficient of 1 is the easiest to isolate for. 3x plus y equals 3, or y equals, subtract 3x to the other side. Y is negative 3x plus 3. Agreed? Okay. Step 1 is not bad. Step 2 is log. Because what are we doing in step 2 now? Yes.
It's not hard to remember, it's just it takes so much effort.
Yes, it does. It's not that hard to remember. So that was equation. We rearranged which equation? 1. So we're actually going to put 1 into 2. So we're going to sub 1 into 2. So I find it helpful to write out equation 2 first. And then maybe even just circle which variable we're replacing. Which variable are we replacing? Why is it y?
Because it's y.
Because we made it y equals. Okay, we made y equals, so we're replacing the y. That's why. Yeah. Okay, when you replace, use brackets. So 7x minus 2 times, what's y? Okay. I'd like you to do the algebra from there. Solve for x. Okay. Use distributive law. Get rid of those brackets. Collect like terms. Put x from one side, all the constants on the other. Plus 6x minus 6, because you're just splitting in the negative 2, equals 20. Or 13x minus 6 equals 20. Then we isolate x. Add 6, so 13x equals 26, meaning x equals 13 times 2 is 26. Divide both sides by 13. 26 divided by 13 is 2. Right? I skipped a step. I didn't write the divide by 13, divide by 13. Okay. What's step 3? Okay, in your solution, you have to figure out what x equals and what y equals. So common mistake is to stop here. You're like, oh, I found x. Awesome. All done. No, a solution has an x and a y, a coordinate. We only know the x. So how do I get y? You know what x is. X is 2, and we're going to sub it into either equation. Which one do you want to sub it into? Bob. Bob is 1?
Yes.
Okay.
Bob is always 1.
Bob is always 1. Okay, so you can use the original 3x plus y equals 3, or you can use your rearranged one. I'm going to use my rearranged one. We said y is equal to negative 3x plus 3. So negative 3 times 2 plus 3 is dun, 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 negative 3. Okay, what's our last step? Check. What? Slow down. Step 4 is our check. Okay, where am I? So we have our solution. If I wrote it as a coordinate, what would it be? 2 comma negative 3. X is 2, y is negative 3. For check, we want to sub it into both equations. It should be true for both. 3 times 2 plus or minus 3 has to equal 3. Does 6 minus 3 equal 3? Yeah, so you want 3 equals 3. And then 7 times the x minus 2 times the y has to equal 20. Where am I getting these equations from? The original question. These are the original equations. 7 times 2 is 14, what's negative 2 times negative 3? Plus 6, good. Does that equal 20? Yes. All right, are you ready to try B on your own?
Yeah, Bob and Phil.
Bob and Phil, okay? Yeah. I'd like you to give that one a try. Let's all rearrange for y in equation 2 so that we all do the same thing. Step 1. Takes practice, guys. Takes practice. That's what I'm asking you to do. Practice. Sorry. So I'm rearranging the equation 2. 2x plus y equals 0. For y, because the coefficient is 1, a lot easier, and you're going to avoid fractions. Okay? So y equals negative 2x. Step 2. So which equation are you subbing that into? 1 into the first. If you sub it into itself, everything will cancel. You won't get an answer. You get 0 equals 0, right? So, because they're the same lines. So, sub it into the first one. The first equation was 5x minus 3y minus 11 equals 0. Which variable are you replacing? Y. Because we have y equals, I'm replacing the y. Five x minus 3. Whenever you replace, put it in brackets. Instead of y, you're going to write negative 2x. Okay, so now it's algebra. 5x, negative 3 times negative 2x. Plus 6x minus 11 equals 0. Or 11x minus 11 equals 0. Now we add 11 to the other side. We're going to move the 11. Divide both sides by 11. X is equal to what? 1. X is 1. Step 3. What do we do for step 3? Find y. Okay. Find y. Step 3. Okay. Which equation did you sub it into? Negative 2x. So we know x equals 1. So subbing it into y equals negative 2x, equation 2, is the easiest way to go. What's y equal to? Negative 2. Yeah, way easier. If you did the other one, it's more work. Yeah, silly guy. You guys are crazy. Why would you do the ugly way?
Because it was on top.
Okay, so your check, you want to use step 4 is our check. Both equations. 5x minus 3y minus 11 should be 0. So we sub in x was 1 and y is negative 2. 5 plus 6 minus 11, does that equal 0? Yeah, 0 equals 0. And 2 times 1 minus 2, does that equal 0? Thank you, Seth. 0 equals 0. Okay? One more question, you can call it a day. Yes, I know you're working hard, I know you're tired. Skip the next question, the word follow, and go to the next word follow.
Oh, word expert.
Okay, we're talking about the recital, dance recital. Okay? Turn to the dance recital question. Okay, is everyone up is down? We're good? Ethan, you're okay? Looks like you're dying. Yeah? Okay. I know this is a tough day, but you'll be thankful tomorrow, I promise. I'm sure. I'm positive. Yes. Okay, these type of problems, when you have a total number of people and a total amount of money, you can use a chart to help you out. Okay, so this problem says, at a dance recital, there are 220 people. So that's a total number of people. Tickets cost $9 for an adult and $6 for a child. The school collected $1,614 in ticket sales. So I have a total amount of money and I have a total number of people. We can use a chart if it's helpful. How many adults and how many students? So the first thing you have to do is choose your variables. Now your variables are hidden inside the question. The question is what? How many adults and how many children? Those are my variables. That's what I'm looking for. So the number of adults we can call what variable? Can we use A? Because then I don't have to be like, who is X again? Who is Y? Okay, who's Bob? Who's Bill? Okay, so let's use A to be the number of adults at the show, the number of tickets for the adults sold. And how many children will make C, number of children. So when you have a total number of money or number of child. No, yeah, it has to be number of child. Okay, so how do we make a chart? Well, we have adults, and we have children. So we have two different things.
Can we write in all caps?
I don't know, why not?
It's an adult thing. I've noticed that.
Sometimes I like to distinguish between non-caps, you know what I mean? I don't know. Okay, I don't know. It's a good question. Yeah, it is an adult thing, hey? Okay, so the first category, there's 3 boxes here. Or 6 actually. Well, actually 8. Okay. 3 columns after the titles, 2 rows. Okay, so the first column, you're going to write the price per ticket. So adults, what was the price per ticket? $9. Children, the $6. Okay, good. The second column is the number of tickets. So how many adult tickets did we sell? Okay, what do we call that? That was our unknown. What variable did we use? A. And for children we used C. Okay. The last column is the money collected. So how much money did we bring in for the adults? Well, if we know it's $9 per ticket and there were 8 adults, then 9A, we just multiply those together to get how much was collected from adults. So for example, if I sold 2 tickets and they're $9 each, how much money from adults? 18. 2 times the 9 is 18, right? So how much money did I collect from children? 6C. Okay, and the last is our totals go at the bottom here. So what was the total number of tickets sold? 220. And how much total money was collected? 16. That's the proper way to say it. There you go. $1,614. So the cool thing about this is we have our 2 equations. Let's bring out the magic pen. Magic. There you are. So here's one equation. So you don't have to use this method, okay? But you can. A plus C. Yeah. A plus C equals 220. There's one of our equations. So the chart can help you. You might be able to actually get this without the chart, and that's A-okay. So first equation is A plus C equals 220. And remember, we did a question like this before. All the money goes together. And sure enough, here it is. Where's my magic pen? Okay, so 9a plus 6c equals 1,614. There's our second equation. All right. So go 9a, all the money goes together, plus 6c equals 1,614. So there's our two equations. All right, now let's use substitution. Hooray!
No.
Who should you rearrange? Who will be easy?
C.
Okay, A or C and 1. Let's, for consistency, do the same variable. So which variable? A it is. Okay, so let's rearrange 1. So step 1, let's solve for A in 1. I don't know why I circled the 1.
So did
It's such a habit. Okay, A plus C equals 220, meaning first step, we're getting A by itself. So subtract C from both sides, and I get A equals negative C plus 220. Beautiful. Step 2. We're going to sub that equation 1 into the other one, into 2. Oh man, Haley. Okay.
I didn't know that was gonna happen.
I know. Nothing. Okay, so we know A is equal to negative C plus 220. So I'm replacing the A variable with negative C plus 220, because that's what A equals. And then it's the fun part.
No.
You don't think the algebra is the fun part?
Not
This is like grade 9 algebra, isn't it? Or grade 8? It's fun.
I failed right.
Oh, so maybe it's not fun. 9 times negative C. Negative 9C. 220 times 9. Help me out here.
100.
Oh, 1980. Right. I wasn't born yet. Not that old. Okay. Plus 6C equals 1,614. All right, now what? Like terms. Negative 9 plus 6. Negative 3C. Now what? Subtract 1980. And that gives us negative 366. No? Okay, good. And then divide by negative 3, and we get 122. Close-ish. Step 3, how do we get, we're not done, we're halfway. So we just can do 220 minus 122. We know the total number is 220, right? So if I also could use negative, that equation I have over here, 122 plus 220. It's the same thing as 220 total minus the number of adults will give me the number of students, which is how much? It's how much? 98? I think it's 98. 98. Okay, and the last step, step 4, which is here, verify our solution. So we need to just check. Let's use 9 times our C value plus, oh, oops. It's 9 times A, isn't it? Yeah. Guys, I know you're running out of steam, but we're almost there. And 6 times 122 has to equal to 1,614. Let's check. 9. Sorry. Does it work? We're good. Woohoo. Okay, we should be doing it for both. Does 98 plus 122 equal 220? Yes. Very good. So we're, and then the last thing is we have to word problem. Therefore, there were, you could just make it short and sweet, 122 children and 98 adults. Okay?